So we have a function here, and we'd like to find its derivative. Now, when I look at this, the first thing that I see are three smaller functions being multiplied together. We've got the x squared, the sine, and the cosine. Whenever I see functions being multiplied together, first thing that comes into my head is, can we use the product rule? Well, we'd certainly like to, but the product rule doesn't directly apply to this because the product rule tells us what to do if we have two functions multiplied together. And in this instance, we have three. Okay, but we can use the product rule here. We're just going to have to tweak it a little first. All right, so what I'm going to do right off the bat, I'm going to group the last two functions together. Now, there's nothing magical about the last two. I could have done it with the first two, and we'd have ended up in the same place. So now I have this kind of refactored as two things multiplied together, and that's a situation we can apply the product rule to. All right, so if we do that, we end up with this thing. There's a lot going on here. We have the derivative of the first part times the second, plus the first part times the derivative of the second. It's really just a classic product rule application. Just the second part is a little messier. So now we can actually do the derivative part. The derivative of x squared is 2x. The sine cosine part stays the same. The x squared part stays the same. And now this last bit here, the derivative of the sine times the cosine. This is, again, product rule situation. So if I apply the product rule here a second time, we get the derivative of the first times the second plus the second times the derivative of the first. And that works because I know what the derivative of both of those trig functions are. So if I put those in here, first part stays the same, 2x times sine of x times cosine of x. And the part inside the brackets there, the derivative of the sine is the cosine, and the derivative of the cosine is the negative sine. Now, at this point, the calculus bits are all done. All that's left, and hopefully by now you realize that these problems often come down to this, all that's left now is some trig and algebra manipulation to see how much we can simplify it. So the first thing I'm going to do is I'm going to take those two products here, and I'm going to kind of do the obvious thing. I'm going to replace them with the exponent versions. All right, so now when I look at this, cosine squared minus sine squared, that's cosine 2x. And over here, if you just kind of ignore the x for a minute, we have 2 cosine x sine of x, that's the sine of 2x. All right, so if I make those two substitutions, I get this expression, and that's going to be my final answer. Right? I can't simplify that any further. Now, if you're looking at this, you think, wow, that's interesting. How did cosine and sine both of 2x somehow slip into this? Well, if you look back at the original function up here, I can tweak this just a little bit. I'm going to rewrite this. I'm going to put 1/2 out in front, x squared 2 sine x cosine x. 1/2 times 2, that's 1, right? You can multiply by 1 all you like. And now you see where those double angles were coming from. This is 1/2 x squared sine of 2x. Now, based on what we know right now, we don't have a way to differentiate that sine 2x, right? The sine of x, yes, but that 2 is getting in the way, right? But if you kind of hold on to this problem, because we're going to revisit this question a little later on here, there is a way to differentiate something like that. It's called the chain rule, right? And that's something that we're going to be looking at a little further on in the class. So if you'd like to get the full context, you can click on the upper link here to see the corresponding lecture. And if you'd like to see a related example, the link below will take you to another presentation that walks through finding the normal line to a curve using a situation that's going to use the quotient rule, right? It's kind of the close cousin of the product rule here. So finally, if you like this example or found it helpful, please don't forget to click on the like button down below.